In this lesson, we're going to learn how to pass an array to a function to be processed. We're going to use two functions, one to input data and one to output data. Okay, so we already have one function called main, so we're going to need two more functions, one for data input and the other one for data output. So what I'm going to do is start with a simple prototype for either one. Okay, so I'm going to have a function for data in, and it will take two parameters. One will be a pointer, and the other one will be an integer related to the size of the array data in will be handling. Okay, so it depends again on what kind of arrays you're going to pass to these functions. Let's do an example where we're going to pass a numerical array where we're going to store double type in the array. So in that case, you need double asterisk, okay? And let's call it our array PTR right here, okay? And then you need int size right here, okay? And right now, we could put a semicolon here and leave it as a prototype, okay? And then define them after main. So let's do that for now. And this is the strategy that I'm working with. So here, void data out. So this will display, right? So, and again, it will do the same thing. You need a pointer. And you need an integer value for the size of the array so you don't go over what you need to do. So these two here, we can put a comment for each one. This one here will process data inside or to be stored in the array. And this one here will process data to be output or to output, process data to output to the screen. Okay, good. So now in main, we're going to declare the array that we're going to need. Let's suppose that array is going to be called myArray this way, okay? And we're going to need to set up a size for this. So we could, right prior to that, do an int array size if you want, and give it a 5, okay? Now you can go as long as whatever array size you need. And notice here, this is a good practice. Now I could have put 5 in there and we're done. But I like to use a variable to set the array size ahead of time, okay, at compile time. Now, what you're going to need is you need to call the function to populate the array. And then after you're done, call the function to print the content of the array. Now, at this stage, I have two prototypes. I don't have these functions yet, okay? But I do know how to call them, okay, based on their prototypes. At this stage, good time to go ahead and compile. Okay, so as you can see, no news is good news. I did not call them. They don't exist, these functions yet, right? So if I do call it, I will get a compiler error. So let's try to call it. So how do you do that? You're going to send data in, and you're going to pass two parameters to become arguments to the function. One is a reference to the array, since the first parameter is a pointer on this side. So here, my array is the prudent way to go. You could say and percent my array 0, comma, and next is our size. So, and then put a semicolon. That's your function call. Notice how simple main now becomes because you're delegating the job outside of main. And then data out. And you're going to do the same thing. And notice how consistent now the code becomes. And our size. Now, this is not going to work yet because we have not defined these functions, exactly how they're going to do the work, okay? If you try to compile it now, right, you get a warning and it says here unidentified reference to data in and data out, which is fine. We did not define how these functions work. So can we do it right here? Yeah, I can do them in a gutted manner. So first, just put curly braces just so the compiler accepts them. So data in, and you could reuse the same parameters that we're using here. I formalized it, and I can show you if you don't want the prototypes to be formal, we could do that as well. And put a curly brace here, put a curly. Notice they're not doing anything yet. I just want them to be defined even though they're not doing anything. And let me just put this right here and put curly brace and close curly brace. At this stage, when I compile this, I shouldn't get this warning here. So let's go ahead and compile. And sure enough, everything is good. Now, let me show you another way to do this too. If you don't want to give a name to or a formal name to the variables you're going to use as your parameters, you can simply state the data type like this for the prototypes. And that would work as fine, just fine. But when you're ready to define, you have to formally say what they're going to be. So these two here are called prototypes. Okay? And your main application starts here, or your controlling function. And here are the functions or function definitions. This is where you're going to define these functions. Let me recompile this to show you that this is just okay. It's fine. Okay? So this is one way to do things, is if you want to do an informal prototype, which means you don't necessarily need to put formal arguments. You could do it this way by showing the signature of the function. Double asterisk int, double asterisk int. Because you don't know what you want to name those variables. You just simply know the pattern that you're going to follow eventually when you're ready to do the implementation right here. Okay, so now let's do data in. Okay, we know we have access to that pointer. Okay, so we could use a for loop now based on size. So we could do something like this: for int I equals 0, I less than size, since you've passed size, our size to size, right, when you call it, and I plus plus. Let's put a couple curly braces here. We're going to do a couple things here, just like we did before in our previous videos. Same idea. Okay, you have a pointer. You can dereference that pointer, so you could actually do something like this. See out. Enter element. We could put, just to make it fancy, put I in here. So that will show as element 0, right? So, and then put a semicolon here. CN. And guess what? Asterisk, dereference the pointer. AAR, PTR. So not any different than what we've done prior to this. But make sure that you increment your pointer. Otherwise, you're going to be pointing at the same place over and over. You have to increment plus plus. Sorry about that. Right there. Excellent. Let me just compile this for a second. So this is how you typically would produce your code. So compile every time just to make sure you didn't make any boo-boos here. That looks good. Let's do the same thing for data out. Okay. So this is what we call separation of concerns in a way. So you're writing a function for each job separately. And then you can reuse these functions somewhere else, okay, in another program. You can either copy and paste to another program or store these two functions in a library file, your own personal library file. So again, we need a for loop here. Int I equals 0, I less than size, I plus plus. And we're going to simply print and move the pointer. Okay, now we see how important pointers are, especially when you want to pass a whole array to a function, right? Prior to this, when you needed to pass something to a function, you could pass one element at a time. But this allows you to pass the whole array by passing its first address and then move from there with the pointer to step through all the addresses assigned to that array. So cout, and we could do element and then I, and then we could do something like this, equals, and then we could stream this, dereference the pointer, asterisk, AAR, PTR, okay? Now, you're going to say, wait a minute, in the previous example, we reset the pointer when we got to, before we got to this stage. You don't need to, because every time you're calling this function, you are sending the first address of the pointer. So right from the get-go, this is already the starting address of the pointer. So no need to reset anything. So that's another advantage. Now, remember here, you still have to move the pointer. There you have it. Now, let's see how this works. Let me just put an end L here, just so we can have a new line there. So let me just compile all this. Okay, good. Let's run it. Okay, so it's asking me for element 0. So it right away in main, the first function it encountered is data in. It sent the address of the array over to the function plus its size, right? So right now we're inside of this loop. Once we called in data in, we have access to the first address and we have access to size. So let's go ahead and put some data, 23.6. Next element will be 11.2. Next element was 0.23. And third element will be, or the fourth element, 78.1. And I'm going to put a minus 1.2 for element, the fifth element, which is element number 4, starting at 0. Now, let's see. When I'm done here, it's going to go back to main and then call the function data out and see if we're getting our data. And sure enough, we have full control over how to populate the array or extract the data from the array. The next video, we're going to do a full example of utilization of an array for as a data structure to look at, to do some analysis. For example, let's say we have a series of numbers. We want to do a statistical analysis, like which one is the highest, which one was the lowest, and what was the average.